Find the phase shift for these two functions. We have y equals sine of x minus pi over 4 and y equals sine of x plus 2 pi over 3. Well, what does a phase shift represent? Okay, so phase shift tells us the horizontal shift of these graphs, right? Essentially, where do these graphs begin? Okay, now let's say we just want to draw the graph of sine of x. Okay, so notice there's no amplitude, there's no period, there's no phase shift here, right? There's no plus or minus, or we're not multiplying by anything here, right? The idea is that we always start at 0 for sine. Okay, so this is the starting point. Okay, and we know, of course, that this is 2 pi. The amplitude is 1, negative 1. Okay, but we always start, for sine, we always start at 0, 0, right? Okay. So the idea is that, well, what does this do to the graph? Or what is this, right, whenever we add or subtract? Okay, so what we want to do is we want to look at sort of the base function, right? We got a times the sine of bx minus c. Okay, and what the c does, or c over b, I should say, okay, the c divided by b gives us the phase shift, which is a horizontal shift. Remember, the phase shift basically means what is the horizontal shift. Okay, so you got to be careful with the sign, right? Okay, because the minus is built in here. So if this is positive, okay, we shift to the right. If this is negative, we shift to the left. And you got to be very careful with this. Okay, so that's what we want to do. We want to calculate what c over b is, and then just do that horizontal shift. Essentially, just moving this left or right. Okay, so what about this guy, right? So we'll do, let's do it right here. Y equals sine x minus pi over 4. Okay, we notice that here a is equal to 1 and b is equal to 1. Okay, so there's no amplitude here, there's no period change here, right? But we see that c is equal to a positive pi over 4. Okay, this value here, right? Remember, this minus is built in. Okay, so the phase shift, in this case, we're going to get c over b, so just pi over 4 over 1, which is just pi over 4. This is going to be to the right. Okay, let's think about what that means. It means that instead of the graph starting at 0, 0, as it does here, right, we're just going to shift it to the right pi over 4 units, and then that is our graph of sine. Okay, so it's going to start here at pi over 4. Okay, so that's the phase shift, right? That's called the horizontal shift. What about this one here? Right, y equals the sine of x plus 2 pi over 3. Okay. Once again, a is equal to 1, b is equal to 1, right? C is equal to negative 2 pi over 3. You got to be careful with the signs once again. Okay, so that means c over b, or the phase shift, is just, well, in this case, just a negative 2 pi over 3. But remember, that means we go to the left. Okay, so our phase shift will be to the left. Okay, what does that mean? Okay. So once again, instead of starting at 0, 0, as the graph of sine normally does, right, we are going to shift this to the left, negative 2 pi over 3 units. Okay. So that means our graph is actually going to start here. So if we draw this graph here, then we just draw the normal sine graph as we normally would, right? We go up, we come back down, and then we end back over here. Okay. Now just a note about this, what is this point here? Okay. The period is 2 pi, right? That does not mean that this point here is 2 pi. Remember, the length from beginning to end, this is one complete wave, right? The length is 2 pi. So how are we going to determine what this point is? Okay, well, we take the starting point, which we know is negative 2 pi over 3, and then we just add the period to that, right? That's going to be the length. Okay. So what does that make this point here then? Well, we just add these guys together. Of course, we need the LCD, right? This becomes 6 pi over 3. So negative 2 plus 6 gives us 4 pi over 3. That's going to be this point right here. This point here is the point 4 pi over 3.